Welcome back to Knifer Middle School. Force and Motion, Grade 6 Science. We are taking a look at Goal 6. Students will be able to explain and apply Newton's second law. Let's check out a video to see what that is all about.
Now, what are you doing, Mike?
Well, science in a fun way and hopefully make them enthusiastic and try to get them into some of the science and math and technology fields, which they're struggling to do right now. Did I cover that, Aaron?
You have it exactly right. That's right.
Listen really good.
That's right. We're going to learn right here, right now, actually.
Okay, so what are we doing?
Well, we're going to demonstrate Newton's second law, force equals mass times acceleration. Okay. Now, this is a small mass here, so you only need to use a very minimal force to put the ball into the net. So there we go. There's a goal right there. Nice and easy, but we're going to increase the ball's mass and try it again. Now, because it's a bigger mass, you need to accelerate your leg and create a greater force. So there you go, another goal. See, we're all learning right now, but watch out right here. Oh my goodness. Now, we don't know if you can create the force needed to move this much mass. So give it your best shot. 3, 2, 1, kick it, get in there. Oh my goodness, watch out now. All right, try it again, a little bit harder, a little more force behind it this time. Bang, there we go. Oh, he cheated a little bit there. You see, he accelerated his mass forward, and that's how you were able to demonstrate Newton's second law.
And it hurts too. Sometimes science is very painful.
All right, here we go. Let's check out Newton's second law. According to Newton's second law of motion, acceleration depends on the object's mass as well as the net force acting on the object. So I've got two pictures here. First of all is the golfer. He is applying a force, but you'll notice the mass is a really small m because it's only a golf ball. It's got a small mass. So since it has a small mass, it'll have a large acceleration. If you take that same force then and apply it to a larger mass where the mass is huge, you get the large m, as you can see in the picture right about there. You get a very small acceleration, if any at all. So one of the things we want to pay attention to is not only is there a formula for Newton's second law, but there's a concept. The concept that the amount of force depends on the mass and the acceleration, as well as the amount of acceleration depends on the force applied to the object and how much mass the object has in it. So if we're thinking about balanced and unbalanced forces, when the forces become unbalanced, that means they start accelerating an object, there is acceleration. The object begins to move. That acceleration depends on the net force as well as how much the object's mass is. Check this out. There's a quick little link here that'll take you to this page. I love this little demonstration because what you'll see here is it says F divided by 2, and F divided by 3, which means that this is a force, this is kind of half of the force, and this is a third of the force. And what you're seeing is the exact same mass. So you can see here that if you apply a force to a mass, we get acceleration. If you take less force to the same mass, you get less acceleration. So see, acceleration does depend on the amount of force on an object. Here's another example. What if I change the mass? Okay? If I make the object heavier. Well, if I make the object heavier but still keep the same amount of force, we will get a different amount of acceleration. Okay? So that gives you an idea of how acceleration does depend on both force and mass. Therefore, Newton's second law of motion is that force is equal to mass times acceleration. Now take a look at these labels, these units. They'll become important here in a minute, but force is measured in newtons. Mass is always measured in kilograms. And acceleration is measured in what's called meters per second squared. Here's a sample problem. If we have this car and it weighs 1,000 kilograms and we want it to move at an acceleration of 0.05 meters per second squared, how fast or how much force should I push this car with? Well, to figure out the problem, F is equal to m times a. The mass is 1,000 kilograms. The acceleration, 0.05 meters per second squared. 100 times 0.05 is equal to 50. Okay? When we want the force, it's going to be measured in newtons. How do we get that? Well, a newton is the same thing as a kilogram times meter per second squared. Obviously, that is a big label, and it just ended up being easier naming it a newton. The triangle we'll be working with, our force formula here, shows that F is at the top of the triangle, mass and acceleration are at the bottom. Meaning that if I give you any problem within this triangle, you should be able to answer it using this triangle. The only problem you're going to run into is remembering mass is measured in kilograms, acceleration is meters per second squared, and force is measured in newtons. So that was goal 6. Students will explain and apply Newton's second law. Let's watch this video to send us out.
The second law is all about a simple formulation. To get the force, just multiply mass and acceleration. If that's too much to say, there is an easy way. Try this abbreviation for the simple.
F equals M.